Have you ever wondered how your brain, a 3-pound organ, gives rise to the subjective experience of consciousness? We experience thoughts, emotions, and a sense of self. But how does this arise from the complex network of neurons and synapses? Some scientists believe the answer might lie in the realm of quantum mechanics, the strange world of subatomic particles. Could our brains be harnessing the power of quantum computation to create consciousness? The idea that quantum processes might be at play in the brain is a captivating one. Quantum mechanics, after all, governs the behavior of matter at the smallest scales, where the rules of classical physics break down. Particles can exist in multiple states at once, a phenomenon called superposition, and can be linked across vast distances through entanglement. Could these bizarre quantum phenomena be happening within our neurons? If so, it could revolutionize our understanding of consciousness. It could also lead to groundbreaking advancements in artificial intelligence, mental health treatment, and even our understanding of the universe and our place within it. Let's delve into this mind-bending theory and explore the potential of a quantum brain. To understand the quantum brain hypothesis, we first need to grasp the fundamental differences between classical computers and their quantum counterparts. Classical computers, like the one you're using to read this, rely on bits. A bit is a binary unit of information, existing as either a 0 or a 1. All the complex computations your computer performs boil down to manipulating these bits. Quantum computers, on the other hand, utilize qubits. A qubit can exist as a 0, a 1, or, and here's where it gets interesting, a superposition of both states simultaneously. Imagine a coin spinning in the air, not yet landed as heads or tails. That's superposition. This ability to exist in multiple states at once gives quantum computers a significant advantage. They can perform calculations exponentially faster than classical computers for certain types of problems. Furthermore, qubits can be entangled, meaning their fates are intertwined. Measuring the state of one entangled qubit instantly reveals the state of the other, even if they are separated by vast distances. Now, how does this relate to our brains? In the 1990s, physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed a controversial theory called Orchestrated Objective Reduction, or Orch-OR. They suggested that microtubules, tiny structures found within neurons, could be the key to quantum computation in the brain. Microtubules are cylindrical protein structures that provide structural support to cells and help transport materials within them. Penrose and Hameroff theorized that microtubules could also act as quantum computers, with their internal structure supporting the delicate quantum states necessary for computation. According to Orch-OR, quantum computations occur within these microtubules, shielded from the noisy environment of the brain. When these computations reach a threshold, they collapse or reduce, leading to conscious moments. These moments are then orchestrated by the brain's neural networks, giving rise to our experience of consciousness. Quantum processes in biology might seem far-fetched, but nature already uses them. The European robin navigates using Earth's magnetic field, thanks to quantum magnetoreception. In photosynthesis, quantum coherence helps plants convert sunlight into energy with near-perfect efficiency. Could our brains also harness quantum phenomena? Nature might hold the answer. Now, while the Orch-OR theory is definitely intriguing, we have to acknowledge that it's still highly controversial within the scientific community. One of the biggest criticisms is that the brain is, well, just too warm and wet for delicate quantum states to survive for any significant amount of time. Quantum coherence, which is really essential for quantum computation, is incredibly fragile and gets disrupted by environmental noise pretty easily. That said, proponents of the quantum brain hypothesis argue that there's emerging evidence suggesting otherwise. For example, microtubules, those tiny structures inside our neurons, might actually be able to maintain quantum coherence for surprisingly long periods, even under physiological conditions. Some experiments have even shown that microtubules exhibit properties consistent with quantum coherence. Although, let's be honest, more research is definitely needed to confirm these findings. And, some scientists are even suggesting that the brain might have evolved mechanisms to protect and use quantum coherence. I mean, if nature can use quantum phenomena for bird navigation and photosynthesis, then why not for consciousness too? Now let's take a moment to imagine where the quantum brain hypothesis might lead us, particularly when it comes to artificial intelligence. If the brain does indeed utilize quantum processes, could this mean that future AI systems might be designed to mimic these quantum mechanisms? Think about it. AI that doesn't just process data but experiences a form of awareness, even creativity, rooted in quantum principles. Some researchers are already exploring the possibilities of integrating quantum computing with AI. Quantum computers, with their ability to process complex probabilities at incredible speeds, could theoretically simulate neural networks on a quantum level. This could lead to AI systems that are not only faster and more efficient but also capable of solving problems in ways that are currently unimaginable. But here's the kicker. If consciousness truly emerges from quantum processes, could AI one day achieve something akin to consciousness? Could quantum-inspired AI blur the lines between human thought and machine intelligence? It's a tantalizing and somewhat unsettling possibility that could redefine what it means to be intelligent, or even alive. Of course, these ideas are still in the realm of speculation, but as quantum computing and neuroscience continue to evolve, the intersection of these fields might just hold the keys to some of the most profound questions we've ever asked. If true, this could transform our understanding of consciousness, AI, and reality itself. Imagine AI that truly thinks and feels, or new mental health treatments based on quantum brain processes. Even if unproven, this theory inspires groundbreaking research redefining neuroscience and physics.